In today's lesson, we're going to talk about force vectors at a given point. So imagine that it's one of our really windy Colorado days with all those super strong gusts, and you've got furniture out on your patio. And so for that table or chair or whatever you want to think about, it's sitting there on the patio, and gravity is pulling it down, holding it in place, right? That's one force that's acting on it. But you've also got that wind trying to blow it across. Is it going to stay put or not? Well, it's going to depend on how strong the wind is, because it's going to depend on how strong that force is that's pulling it down, holding it in place, compared to the one that's trying to push it out of place. That's a very simple example of one object and two different forces acting on it, and we're wondering what ends up happening to the object when we're done. We're still going to do pretty simple examples today just because this is new for all of us. But let's suppose that we have, where that black dot is, that's our object, our point, and there's two ropes or chains or something attached to it. So maybe the tow truck's trying to pull it one way, or maybe there's a crane trying to pull it, or maybe people are pulling on a rope one way, but two different forces pulling. And what's going to happen? Is it going to stay put? Is it going to move to the left or the right, up or down? As we look at the vectors, we've got these arrows saying the one that's labeled 40 here on the right, that one's pulling it up and to the right. The longer one that's labeled 70, there's an arrow on the end of that showing that that one is being pulled up and to the left. So one's pulling left and one's pulling right, and at slightly different angles, and I wonder if it's going to end up going at all left or right. However, both of those forces are pulling it up, and there's no force trying to pull it down. Do you think it's going to end up staying put vertically, or do you think it's going to go down or it's going to go up? Point. So good job. I've got you guys pointing up. It's going to end up going up somewhat from where it is. Just common sense on that. We're going to do this just like we would with a vector addition problem. So we're going to imagine this is our axis right here. So let's start with the 41. It's going into the first quadrant. So Yesenia, pluses and minuses, how does that work? They're both pluses. And so we're going to say positive 40 cosine 30. Will that be the I hat or the J hat force with cosine? Everybody. That's the I hat force. And then we will also have positive for sine 30 for the J hat part of the force. Now, if I think about the 70 for the moment as a separate vector, what about the pluses and minuses for that one, Caleb? That one's going to be negative, positive, because we're in the second quadrant. So negative for the left, positive for up. So negative for the horizontal part. So negative 70 cosine 45 and positive 70 sine 45 for the J hat. And does that look like I wrote down what we needed to? Yes. Yes, thank you. 40s on both of these. At least I've learned to ask you to proofread for me. And I was asking, does that look right before we go on? Okay, now that we've gotten that corrected, please enter both of those on your calculators and store them as I hat and J hat, because we are going to need to use them. Jack, tell me, what did you get for I hat? And include a positive or a negative. Thumbs up, thumbs down for I hat. Griff, what did you get, including positive or negative for J hat? Madeline, what'd you get? Plus or minus? 69.497. Thumbs up or thumbs down on J hat? And does that make sense with what we predicted, that it would be going up? And it's also saying a little bit to the left and up. Compare the two numbers. 14 to the left, 69 up, so not anywhere nearly as far left as it is going up. So if we drew these vectors end to end, we would have one that's going here into the first quadrant, one that's longer and is going this way, but it stops in the negative positive second quadrant. Does that make sense? So here would be our final vector, something like this. So now with your stored I hat and stored j hat, I want to know how long is the green vector and what is this angle from the positive x-axis until I get over to it. Now, hopefully you are entering the square root of your stored I squared plus your stored j squared, and you are entering the inverse tan of your stored j over your stored I, and you're only going to write down the positive angle that you get even if your calculator has a minus sign in front of that. So help me out with this one. Cooper, did you get how long the vector is? The R? 0.06 what? I didn't hear. Thumbs up, thumbs down, everybody getting that? Don't have to write it twice. Since that is how long the final one is, I'm just going to put it out in front of that at angle symbol. What about what do we get for rho? Who's got that? Okay, Wyatt. 77.934. And I am going to write that down separately because that would be the first quadrant. And I know I need to end up in the second quadrant. Now I need to figure out how do I get that green angle theta that I really want. Here is the reference angle that we just found. When you look at the picture, rho plus theta has to be 180. So theta needs to be 180 minus rho. You need to write that down on your paper. Your calculator already says minus rho on it. So you just need to get the 180 in there. So take that minus rho that your calculator already has and do a plus 180. And Griff, what do we have? And don't forget the degree sign. So we got our rectangular form and we got our polar form. Questions from anybody on that one? Okay, next I'm going to talk about some special forces. Sometimes we have some forces that are going straight up and straight down, or straight up or straight down, or ones that are going straight to the left or straight to the right. And we need to figure out how we're going to write those with I hat and j hat, because we can't draw a right triangle for those, because they're right on the axes. And if you think about it, gravity is a pretty common force that's pulling straight down, right? So we're going to run into that in physics quite a bit. So let's think about these axes. Remember, this is the I hat axis. How far left and right are we going? This is the direction we go for the j hat components. How far up and down? So for that vector on the left there, how far left and right does it go? Okay, I'm seeing people holding up zeros, shaking their heads. No, it goes nowhere left and right. So it's 0 I hat. Jack, what about the rest of it? Does that make sense to everybody? What about this one over here on the right, Nicole? How would I need to change that a little bit? Perfect, because it's going down, it would be a minus 7 j hat. So you're not going to do the sine and cosine pieces with ones that are going straight up and down or straight to the left and straight to the right. So let's see what we can come up with on these. Ethan, what would you do for the one on the left? Sounds perfect to me. What about Kit, the final one here? So is that making sense to everybody? Because this next one's going to have a vector like that in it. So a couple things going on here. The 10 is going straight across, like we were just seeing. The other thing is you have to look and notice which way these arrows are pointing. Up to now, we've just said, okay, here's the origin, and we think of a vector pulling it this way or pulling it that way. But we could also have a push force acting on this. So this one does not start at the origin, it started over there and pushed towards the origin. But if you think about it, if I grabbed this chair right here and I wanted to move it closer to the door, I could either stand here and push it, or I could stand over here on the opposite side and pull it. The same result would be that it would be going however many feet towards the door. That much makes sense to everybody. So what we want to do when we have one like this is we want to think about that 10 is the same as if we were right here at the starting point and it was being pulled that way, 10 units. So since I started talking about that, and since we just talked about that on the last slide, we know that that vector is 10 I hat plus 0 j hat. So I could write the 10 for the I hat part, not 10 cosine anything, just 10. I could write the 0 or not on that because it's not going to make any difference if I enter the 0 on my calculator, but I need to at least be thinking about there is no j hat part on this one. Okay, then we're going to take our other vector here that is starting at the origin, going into the first quadrant. And Allie, would you tell me what I need to write for this vector that is 16 long going into the first quadrant? For the I hat part. So I need you to enter those on your calculator, just a plain 10, and then plus 16 cosine 30 for the I hat. And the j hat, like I was saying, you may enter the 0 if you want, or you may just enter that as 16 sine 30, and be sure that you store both of those as well. Yo-Yo, what did you get for the whole final answer, both I hat and j hat? Oh, so you got the j, what'd you get for the j hat? Everybody, and was that a plus or a minus? Everybody good with a plus 8 j hat? So if you can fix your I hat. Emily, what did you get for I hat? And that was positive? Others, thumbs up, thumbs down? So positive, positive. And does that make sense if we drew these vectors end to end like we're used to doing? And then put our final one in there? So now we want to know how long is that final one, and we want to know this angle. Tell me how that angle that I just traced, is that rho, theta, how do they compare? Is theta going to be 180 plus rho on this one? Wyatt, what's it going to be? Rho and theta are going to be the same because we're in the first quadrant. So you're going to write down that theta and rho are equal to each other and are the inverse tangent of your stored j hat over I hat. And you're going to enter that the length of that vector is the square root of your stored I squared plus your stored j squared. And then we're going to write down our final answer. Cooper, have you already done both parts? What'd you get for R? Thumbs up, thumbs down, 25.162. At Yesenia, do you have my angle? Thumbs up, thumbs down for 18.538 degrees. Questions with that one? Okay, one more, but we're not going to do the whole thing. We're just going to do the setup on it because there's one little piece that I want to talk about with it. Notice these are both push vectors. Both of those arrows are pointing toward the origin. So if we wanted to set this up, so my green one, I'm going to move it so that it starts at the origin. So it's going to come like this. What will this reference angle be, everybody? 40, because those are vertical angles. I didn't do the greatest job drawing it, but hopefully you can see on that original picture that those are going to be vertical angles. So tell me about the pluses and minuses, everybody. Plus, minus. Thank you, everybody. One person right here in the front row who answered first. So for this one, let's see if I can get my length right this time. Plus 2 cosine 40 for the I hat and minus 2 sine 40 for the j hat. Did I get that part right? Okay, Jack helped me out with my other one, and this time maybe I'll use the one that I already had drawn here. So I'm going to move it so it's going, starting at the origin, which means it's going into the first quadrant. So it's looking like this. So Jack, how am I going to set that one up? Plus or minus? And do I really need the ones in there? So that's why I wrote it on one and not the other. And that would give me my final vector wherever that would end up. Anybody with questions on what we've talked about today? Then let's work on some homework.